moving, and is it actually recording?
Yeah.
Okay, so I'm going to just leave the audio thing right in the middle. In previous years, I've actually worn it on me and it tracks me. The problem is this new system is too sensitive and tracks me too well. And so I will often just leave it here. This should be good enough. So all the lectures will be recorded. They will be posted online, depending on how well the internet is working at Williams or what I have immediately afterwards. Within 1 to 4 hours of class, they will be up there. If you need to travel for anything, as long as you let me know in advance, that's absolutely fine. And it could be, Professor Miller, if we win our next 3 games and this team loses, we maybe, that's fine. We can always work along that. Any seniors here? Okay, so you have a 5th class this semester. It's called Applying for Jobs or Grad Schools and whatnot. If you need to adjust any deadlines because of something like that, just let me know. Absolutely fine, no problem at all. For those of you who are not seniors, I'm of course still understanding as well, but it's not as bad for you as it is for them. You can see how stressed they will be as the semester as the semester progresses. Okay? If you want to do any practice interviewing or anything like that, I'm happy to do stuff like that. If people want to do a weekly lunch and do Project Euler problems, this is a great website of really interesting, challenging problems that are often trivial to do if you have essentially infinite computing capacity. We do not have infinite computing capacity, and we do not have computers that are almost infinitely fast. So how do you solve really difficult, challenging problems in a reasonable amount of time? And for a lot of things in life, that's the real issue. It's I have a certain amount of time. How close can I get to the optimal answer with the resources I have? If you own American Airlines, what's your objective? To make money. How do you do that?
I guess you want to pack your planes as full as possible.
Yeah, so it should be about flying people and not getting government subsidies or something like that. But the goal is to fly people. So then the question is, how do you figure out what schedule American Airlines should use? There's a lot of really good math to solve this, but to get the exact answer could take years for a given day. But we have ways to prove that we are within a certain tolerance very quickly. So this is the little questions. This is going to be problem solving. For some things, we will come up with exact solutions. Other things, we will have a more interesting result where we will be able to prove a solution exists without being able to construct it. So I had a wonderful thesis student last year who, her thesis was like that. It was on a game that I created using the Fibonacci numbers to play against my daughter. And my thesis student's assignment was to basically tell me how to beat my daughter. I have no pride. I don't mind. So look, Haley, you can talk to your friends. And so Alyssa was able to prove that as long as n does not equal 2, player 2 always has a winning strategy. But her proof is non-constructive. And so imagine that you are an advisor to a candidate for the presidential election. Say, you have a strategy to get 270 electoral votes. Wonderful. What is it? Well, I can't tell you what it is. If you do the right things, you will get to 270. For some things in mathematics, it's not enough to know a solution exists. We need to be able to find the solution. But at least knowing it exists is a good start. It means that the search will not be useless. That there's a chance of finding it. There are lots of different ways to attack problems. How many of you are considering a career as a professional mathematician? Okay, perfectly fine. How many of you are thinking at all about grad school? Okay, grad school in math. Okay, again, perfectly fine. The idea here is to learn skills that you can apply to various things. How do you formulate a problem? One of my favorite classes that I taught here was Differential Equations. It was taught just after my daughter was born, or I guess I started before she was born, and then in the middle of the semester she was born. And I basically taught differential equations as a father with a new kid. So she was my second kid, so I had experience. If a baby is crying, what do you do?
There's so many different things.
There's so many different things. Right, you go down the list. When the baby is really young, you don't know why they're crying. Does the baby want to be held? Does the baby want a bottle? Does the baby want to be burped? Does the baby need a new diaper? Does the baby want to watch the Red Sox? You just go down the list of things to try and hope that something works. After a while, you start to realize which ones are more likely. Oh, this is probably the I'm hungry cry. It's the same thing. How many of you have taken differential equations? Your different ways of solving a differential equation. After a while, you start to realize which is going to be the more likely method to work. Or if you're doing integration, should I do a U substitution? Should I integrate by parts? Should I do a change of variables? You start to get some familiarity, and you have a couple of tools, a couple of go-to things. And the more problems you do, the easier it gets. This class has the hardest final exam at Williams College. The final exam is the Putnam. Is there anybody here who is not familiar with the Putnam? It's a wonderful exam. 6 questions in the morning, 6 questions in the afternoon. Each question is worth 10 points, so there's a maximum of 120. Excellent, good. We like to know what the algebra background of the classes. If you get 1 out of 120, that's a good score. If you've seen the movie Men in Black, where they have this review, this is the best of the best of the best of the best, sir. The Putnam exam is designed to distinguish the very, very best people. So your final exam is the Putnam. You will start off with a 70%. Every point you think you got on the Putnam, I will add to that, and the Putnam, the final will only count as 5% of your grade. The final exam counts for almost nothing in this class. Okay? It's really about doing the homework, speaking up in class. Okay? If you are one of the top 5 scorers in the Putnam, you are called a Putnam Fellow. There are a couple of people who have been Putnam Fellows 4 times. I know some of them. Another one of my friends was only a Putnam Fellow 3 times because it only took him 3 years to graduate from Harvard. There are people like that in the world. I think that's actually more impressive than doing it 4 times. He lost his eligibility. Okay? There are lots of different types of intelligence. The more of these problems you do, the more you have an idea of how to attack them. Any problem I give you, what do you know about it? If you have a problem on the Putnam exam, what must be true about it? There's a solution. More than there's a solution, there's probably a nice, elegant solution. And it is a huge advantage to know something like that. Life is not like that. Your boss can quite easily give you a problem that does not have a solution. All right, so going into some of the mechanics of the objectives, a lot of this I've already covered. It's to learn problem solving. I want to emphasize the techniques and, more importantly, asking the right questions. My wife sometimes gets upset when I say that 95% or more of my job is trained monkey work. Is once the question is asked, so many of us have the same training, it's obvious what to do next, and boom, 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 we know how to look at these problems. If you can think of good questions to ask, that's often where the contribution is made, is thinking of something new to study. This is one of the advantages of going to a liberal arts school and having different perspectives, seeing different ways of looking at things. I want you to learn how to use computers to build intuition. Is there anybody here who does not know how to program in any language? Mathematica, R, Python, C, Java, Fortran, Logo, Basic. Everybody has some programming experience. Excellent. I do not care what language you use, but I want you to have the ability to do some simple code, gather some data, simulate some things, and build some intuition. I used to say that if you knew how to program, you knew basic probability, and you knew basic statistics, you would always have a job. I cannot say this anymore because somebody sued her school when she graduated and did not get a job. Because of the Freedom of Information Act, you can actually download her lawsuit where she misspells words like tuition and has discovered a new type of discrimination, academic discrimination. Her school did more for students with higher GPAs than lower GPAs. And according to her, her 2.6 is just as good as someone else's 3.6. So I will no longer promise my students jobs upon graduation, but I will say it is extremely likely that you will have a job if you have these skills. And this is one of the things I want you to have. A lot of Williams students love this place, and they frequently come back to campus. I've got some students coming back next Wednesday from the analysis group in Boston, which does consulting, often medical consulting. And so I will let you know about opportunities of this to meet with Williams students who are moving up the ladder, who are happy to talk to you, even if you're not interested in their company, to just give you some advice. There is a talk today by a friend of mine from the University of Connecticut at 1 p.m. in Physics 203. It is on, I believe, number theory and the ABC conjecture. If you go to that, you are excused from one homework problem at any point in the semester or a future class with me. You are responsible for keeping track of all the excuse problems you have. This is the honor system. I don't want to have more paperwork. I will try to have a lot of these frequently available so that if you do things, you can start building up a strategic reserve. When should you use your strategic reserve?
Yeah, I feel like it would depend on the person.
Yeah.
Everyone has different things. So maybe you want to be something to focus on. This week you might be an athlete and you just don't have time
Exactly.
Or maybe this one problem is just really hard. And
Yes.
You don't want to have to do it.
No, and those are the two best reasons. Is you are going to have some weeks where things are going to be really bad. It's nice to have reserves. I had a senior years ago who had saved up several of these from multiple classes of me over the years, and basically 2/3 of the way through the semester said, I'm done. And so, perfectly fine strategy. There was one hellish problem I had when I was an undergraduate taking a graduate mathematical physics class. And yeah, that problem was just not worth doing. It was just a long, tedious calculation that you don't learn much from. So I will try to have lots of opportunities like this. Keep them for when you really need them. I want to use these problems as a springboard to see good mathematics. As I was mentioning earlier, we are fortunate. There is no class that has this as a prerequisite. This means if there's something you want to see, let me know and we'll adjust the curriculum. Whatever you guys want to do, within reason, I'm fine with. Yeah, the idea is to see good mathematics and discuss it. The last one might be a little bit harder because a lot of the math competitions are fizzling out. So we are not going to have a green chicken competition with Middlebury this year. I know. I will talk about that when the camera's not rolling. There are other ones we can do. Some of them are remote, so we don't have to travel. All right, but just for those of you who've never seen, this is the green chicken. We used to have a contest with Middlebury every year. Whoever did best got the green chicken. Dick Quinn in the communications athletics department got the Boston Globe to write a story on this. And they actually announced who would win at the football games. And people asked him, why the hell does athletics care? And he said, if you mention Williams and you keep score, I care. And this is one of the things I love about this place, about how all the different parts work together. And so as a nice way to reciprocate, whenever Williams would win the Directors' Cup, we would actually put something on the Math Stats homepage and just announce how well the teams are doing. This is the brown chicken. The brown chicken belongs to me. When the Boston Globe ran the story, there was somebody in Central Mass who contacted me and said they got this as a wedding gift. It's been in the closet for 40 years. And I said, I'll be there Friday. So we actually do have the brown chicken as well. She can come and visit. All right, course mechanics. Homework mostly going to be due Fridays, 15%. Book editing, 15%. So I am the problem editor of Pi Mu Epsilon, the undergraduate math journal. There are 2 issues a year. Any school with students who solve at least 2 problems is entered into a drawing to win a free pizza. So you are welcome to work with each other, but I can't help you because as the problem editor, there would be a little bit of a conflict of interest. But I am writing a book with a colleague at Pomona College celebrating 100 years of Pi Mu Epsilon. And I did this when I first got the job as editor because I wanted to have something for a couple of issues. And so we have 100 problems, 1 for each year. And the reason I want you to work on this is this will let you see some really good mathematics. It will really talk to you about how do you write mathematics so people can read it and understand and be excited about it. So a huge part is basically communicating. This is why all seniors have to give a public talk before they graduate. Is there anybody here considering a career in mime? If so, don't speak up. All right, so nobody's thinking of being a professional mime. You will then be in a career where you will have to speak with people, either in person, by video conference, or by written word because you will not be senior enough to go to the meeting and you will have to give a report that's read. This is why it is so important to work on exposition. This is why 15% of the class is going to be from that. The project Euler problems will be 15% as well. This will be learning how to do interesting problems. This does not mean you have to be getting, there's over 400 problems that get extremely hard. This does not mean you have to be able to do the extremely hard problems. And absolutely fine with collaborative work. Just clearly write down who you work with whenever you do anything together. So prerequisites, you're supposed to have had linear algebra. If anybody hasn't had linear algebra, let me know. Office hours. It would be wonderful if Williams was able to mention to us when rooms would be available once the semester started. In terms of the list of things, that would be wonderful. This is low on the list, but it is on the list. So once Williams lets us know when we can have rooms, I will let you know when they will be. I am also not setting my office hours right now because I know some of you might be considering various classes, and so your schedule is not fixed. So I don't want to fix my office hours until I know what hours work for you all. All right. Feedback. If you want to email me, you can email me either directly, or if you would prefer to do it anonymously, you can use efmaths@gmail.com, password 1793 Williams. All I ask is not change the password. Somebody did that a few years ago, and it was not fun. Okay? But it doesn't have to be about this class. If there's a concern you have, either with the department, with another class, with something at Williams, you can try national and international issues. I have less say in those. But this is a chance for you to just put something on my radar screen. All right, webpage, this will be emailed to you. In previous years, I've been doing additional comments from every day. Since I've taught the class before, I'm going to just leave the additional comments from last time, and then you're welcome to read them. If there is something that we did in class that I haven't posted you'd like to see more on, let me know. Again, one of the nice things about this is I can adjust things based on what you're interested in. I talked about the book, and then I also maintain a math riddles page. So if you're interested in something like that, this is one of the top hits when you Google math riddles. It's being used in a lot of schools all over the world. There is a teacher's corner, and it has ways to look at these problems. So it's almost like a rocket booster where you have different stages of hints. And the real question is, how do you get somebody to the solution without giving it to them? How do you give them that just a little bit of a nudge? All right. I want to talk a little bit about being prepared. You never know when an opportunity will present itself. Hopefully you can recognize who this person is. So my thesis advisor, turns out when you get old, what math professors really like is birthday conferences. That's really the appropriate gift. So instead of doing it on his 60th birthday, we did it on his 61st birthday. I was not one of the organizers because my advisor had two Steve Millers born same year, same city, both working with him. And so the other one was formally one of the organizers, but I was still helping out with a bunch of things. And there were a couple of people who were going to say a few words at the banquet at the Institute for Advanced Studies. I was not one of the people who was asked to say things. I was not insulted at all. But I prepared a speech just in case. And not only did the people who were told they were going to speak, but they also spontaneously asked a couple of people, would you like to say a few words? I think I could have winged it and said something nice, but I was prepared. I had already thought about what would I like to say with some of the top mathematicians in the world about how much this person meant to me and my development. So you often don't know, and sometimes you will do preparation and it will not matter because the opportunity won't arise. But if there's a chance, prepare for it. When you're interviewing with companies, see if you can look up who's going to be there. Anybody ever read the book The Firm by John Grisham? Or see the movie? The book is better than the movie. So there's one scene, the main character is a law student at Harvard. He's one of the top students there. He's being recruited by a firm. And he's being interviewed, and the firm really wants him. And one of the partners says, so where'd you do your undergrad? And he basically says the name of a really bad school because he was from a poor family, started off at a poor school, but worked himself up to a good law school. And the partner just said, oh, you went there? And he just realized, oh my God, I didn't mean to insult this person we're trying to recruit. And without batting an eye, the law student said, it's not a bad place. It's about as good as, and mentioned the name of the school that this person had gone to, which also wasn't a named school. And what impressed the people was he didn't know who he was going to be meeting with. He researched all the partners and had the information on quick available recall. When I was interviewing for jobs, this was back before I had a smartphone, I had a piece of paper with the names of every professor at the school I was interviewing at in math. And I had one or two sentences as to, if I saw this person, what would I talk to them about? And before each meeting, I would quickly look at this. Whatever preparations you can do, I strongly urge you to do. Okay, so your job is to be prepared for class. If there's reading, you should have the reading done. If I ask you to think about material, you should be thinking about it. Come to me or the TAs or each others if you have any questions. Our job is to provide you resources and guiding questions and to be available. This is the nice thing about being in a school like Williams. So here is some advice from my brother, 3 pieces of advice. Party less than the person next to you. For those of you sitting at a table by yourself, you're going to have a very productive semester. Take advantage of office hours and mentoring. When you get into the real world, you will not always be fortunate to have people around who want to talk to you, who want to spend time with you. Not just me, not just the TAs, but there's plenty of opportunities at Williams to talk to people, from people who are visiting. Take advantage of that. And the last is learn to manage your time. No one wants to do this. So what this means is, if possible, read ahead. Now again, in a class like this where things are often in flux, this is not as easy of a class to get a strategic reserve in terms of material. But if you have some other classes right now, I urge you to have a painful weekend and read ahead in your other classes and build up a reserve so that when something happens, a roommate has a crisis, you have a crisis, health issue, unexpected opportunity where you have to travel, you want to have those reserves. Right? As I said, I'm happy to do practice interviews, happy to adjust deadlines. Some useful links. How many of you have never used LaTeX? Okay, so LaTeX is a wonderful environment that basically allows you to do scientific processing. So it's a combination between like a word processor and a programming language. It allows you to write math beautifully. I have some handouts on how to do this. Basically what you do is you take one of the template files and then you change the name to my template file and you just play with it. The template file I have made, the text actually describes what the code does, so it's pretty self-explanatory. It takes about an hour to learn how to use it, and if you're lucky, no more than an hour to download it. I will have handouts, and I also just have some general advice. How do you give a talk? How do you write things up? Maybe how do you do an interview? All right. Any mechanics questions up till now? Yes?
Do you have TAs?
We have a TA for this class. TA is Hunter Wyman. He took this class with me the last time it was offered.
Okay.
And so we are still waiting to find out when rooms will be available so we can figure out when the TA sessions will be. Any other mechanics questions? Okay. Let me try that again. Okay, there we go. Okay. So now let's see. This is the slow installment plan. All right. So we've got a bunch of time now. Let's start off in 6th grade. So I was mentioning to some of you that I do not believe in age-appropriate mathematics. When I go to the elementary school, I give them the same math I give you guys, and vice versa. So my son had a really good math game yesterday. So they call this game 20. There's lots of different ways you can play this, lots of different variants. And the goal is not to say the number 20. It's a 2-play game. You alternate going. And on your turn, you either say 1, 2, or 3 numbers. So the first person says either 1, 1, 2, or 1, 2, 3. You have to speak in order. So let's say the first person says 1, 2. The second person can then say either 3, 3, 4, or 3, 4, 5. Okay? Everybody understand? Anybody want to try to play me? I'll even let you choose if you want to go first or second. Or does anybody want to play anybody else in the class? Does anybody want to challenge somebody in the class? Do you two challenge each other?
He says he knows how to win.
Okay.
Play the teacher, do it.
Do you want to go first or second?
Wait, I didn't count. I'll play. I think I want to go first.
Okay.
1, 2, 3.
So
4, 5.
Wait, 1, 2, 3. Okay, then you did 4, 5. Okay. Interesting choice. Interesting choice.
6, 7. 8, 9. 10, 11. 12, 13, 14. 15. 16, 17. 18, 19.
A valiant effort, but all for naught.
Yeah. Because if you said one number, then you would have forced
Oh, I
him to say
would've won.
20.
What? I said 2 numbers.
Yeah, you should have said just 6.
Whoa.
You can say 3. 18, 19. Yeah.
Because you can only say 3.
I'll start to get to people know your name instead of just red shirt.
Clay.
Clay with a C.
Yes.
And
Yo.
so at this point, Yo has just done 17. So at this point, you're dead. Because you're going to go 18 and 19. Right. So let's go over here. So Clay has gone 15. If Yo had just done 16, he would have said 17, 18, 19. 16, if he had said 16, 17, 18, he would have said 19. So at this point, Yo is dead. As long as Clay doesn't misplay, there's nothing you can do. You've lost at this point. Okay, let's keep going backwards over here. So we had ended with Clay at 11. And I'm going to claim that Clay had already won at 11. So at this point, if Yo does 3 things, then Clay gets 15. If Yo had done 2 things, then Clay would have just done 14, 15. If Clay had done 1 thing, you would have done 13, 14, 15. So what we're doing is we're trying to look at a key place and then push the analysis, pull the analysis backwards. So at this point, you still have the victory. And so I'm not going to continue doing the analysis. I'll let you think about this. If you have suite mates, if you have friends, hopefully at least one of those is a non-empty set. You can try playing it on them. If not, call up your families. Maybe you have younger brothers, older brothers, sisters, whatever. And try to see if you can figure out what the strategy is. Which number does Clay really want to make sure he gets? 19. If Clay has 19, Clay has 1. And then you can say, okay, so if I can get to 19, I know whoever says 19 wins. And then try to pull that back. So I don't want to do the full analysis now. So then I told my son, well, let's see if you can tweak the game and beat your teacher. So how could you change this game? This is all about asking questions. What else could you do?
Changing the amount of numbers you can say.
So one thing is you could change the number of numbers you say. So here we can only say up to 3 numbers. What if you could say up to 4 or 5 or 6? How does the strategy change on that? Turns out, straightforward change. What else could you change?
Change the target.
Change the target number, right? It could be that if you play this game properly, player 1 is always going to win. Or if you play it properly, maybe player 2 always wins. So maybe different choices of numbers. It is not interesting. I'll phrase it like this. Agree or disagree. If the game is always going to be won by the first person if they play properly, the game is not interesting. Do you agree or disagree? If the first person can always win if they play properly, the game is not interesting. This is a really general statement.
I feel like it could not be interesting only if that person always knew what the strategy was, but if they didn't, then it's just...
Yeah, can you give me an example of a game where the strategy may not be clear?
Chess.
Chess, right? I still consider chess an interesting game, even if it might be if it might be knowable eventually that player 1 has a winning strategy. Or perhaps player 2 has a winning strategy. Or maybe a weaker statement is true, player 1 has a strategy to guarantee at least a tie. Any chess players here? So I used to be highly ranked. At my prime, I could actually play 2 grandmasters simultaneously and do no worse than tie on both boards.
You do competitions.
Mm-hmm.
As if you played one against the other.
Yes. So I'll play 2 grandmasters. I'll be white on your board and I'll be black on your board. So since I'm black on your board, I'll let you go first, and then that will be my move on your board.
Wow.
So a lot of mathematics is just how you phrase things, or a lot of life is how you phrase things. It sounds really impressive. I could play 2 grandmasters. Now, if I had to play just 1 grandmaster and I was white, I'd be destroyed. But again, it's not lying. It's just a very careful emphasis. So again, another thing is for games like chess, what's another good game like chess where it may not be clear, but there could be a winning strategy? Go. Go is another wonderful example. The computers are beating humans in chess. I think we're still beating the computers in Go, but I'm not sure anymore.
No.
Computers are not beating us. Well.
Yeah.
So checkers, I know, has been fully solved by computers, by brute force computation. So again, even if the game is determinable, if you can't determine the winning strategy easily, it could still be interesting to play. This is not one of them. The winning strategy is not that bad. It's a good thing to keep thinking about. So you can change the target number. You can change the number of ones you can do. And then my son had another nice twist. So you know the strategy for this, correct? Do you know the strategy? Yes.
I think so.
Okay, so I'll let you ponder this. What my sense is, well, now what if you only can do 1 or 2 numbers and you want to get to 20? Is the game now interesting? And so how do you change the strategy now where you have something like that? Well, or is this really just now the same as doing... Depending on how you phrase things, it could look like a really difficult generalization, but it's really not. So I'll leave this as something for you to think about. Okay? So since we were speaking of chess, this is the first day of class, just want to give you some general things to look at. Let's see, we have 2 ways to start. 1, 2, 3, 4. 1, 2, 3, 4. Is there anybody here who has not played chess? Everybody's played chess. Okay. So due to budget cuts, I needed money to buy the Rubik's Cubes, so I don't have enough to buy a full 8x8 chessboard, so I bought a 5x5 chessboard. And what I want to do is I want to put down 5 queens in such a way that 3 pawns can be safely placed on the board. So I can't put a queen on top of another queen. Okay? So my first question is, does everybody understand? I want to put down 5 queens so that there are 3 spaces not being attacked. Okay? Do you think this is a hard problem? Let's say your entire semester grade depends on this. Would you be happy? Why would you be happy?
You could just you could just go through the whole thing.
So you could do a brute force search. How many configurations do we need to check? How many ways are there to place 5 queens on this board? 25 times?
24 times 23 times.
Okay, so one possibility is 25 times 24 times 23 times 22 times 21. If I really cared about you, I'd multiply that out. I don't. I think you can do a little bit better than 25 times 24 times 23 times 22 times 21. What could you do to make it a little bit better?
Transpositions.
Reverse backtracking.
You can divide by 5 factorial. Because what you're doing is you're saying there are 25 squares for the first queen, 24 for the second queen. Well, it doesn't matter if I go queen, queen, or queen, queen. That's really the same. So another way of doing this is I can improve it to 25 choose 5. 25 factorial over 20 factorial. 5 factorial. So it's basically the above divided by 5 factorial. 5 factorial is what, 120? So that's a savings of essentially 2 orders of magnitude. 25 all the way down to 21, it's not that large of a number. So a computer can do this with brute force without too much trouble, but saving a factor of 100 is not bad. Okay. Now there was another comment that was made. What was the comment?
Transpositions.
What do you mean by transpositions?
Like symmetrical positions.
So symmetrical positions. So I believe I am still the reigning tic-tac-toe champion at the elementary school playground. I have yet to lose. And I'm not challenged that often anymore. My reputation is... But when my kids were younger, their friends would go up to you, I'm going to beat you today. I'd let the kids go first. Look, take the victories in life where you can. Okay? For my thesis student, part of her thesis defense was I actually pulled my daughter out of school and had my daughter play her live during the thesis defense. And I let Kayla go second, so she actually had the chance to win, but Kayla made a mistake, and she was very upset. Fortunately, we were meeting a prospective Williams student later that day, and so they played, and my daughter beat him. I don't think he's coming here. But, so let's go to tic-tac-toe. If you go, this is a non-standard class, okay? If you play tic-tac-toe, if you are a little kid How many opening moves do you think there are in tic-tac-toe? If you're a little kid. 9. And then how many responses? 8. So you think there's 72. But really, how many opening moves are there in tic-tac-toe? 3. You can go in one of the corners, you can go in one of the middles, or you can go in the center. There's really only 3 opening moves in tic-tac-toe. If you go through and then look at all the different responses, if you go in the corner, there's 5 responses up to symmetry. If you go in the middle, there's 5 responses up to symmetry. And if you go in the center, there's only 2 responses. So there's only 12 initial pairs of moves in tic-tac-toe. That's a savings of a factor of 6 from 72. So I really only have to be familiar with 12 initial configurations after move response. So whenever you can do something like this to simplify the problem, it's worth considering. It's not the same as it's worth doing. So when I was a young PhD graduate, I spent a summer as a postdoc at the American Institute of Mathematics, and there was an interesting challenge problem. Take the digits 1 through 9 and form 3 fractions, where the numerators are 1 digit and the denominators are 2 digits. Use each number once and only once. So maybe 3 over 45 plus 7 over 98 plus 1 over 26. And if you do it properly, you can actually get this to equal 1. So there's a way to do this. So I'm surrounded by some of the best number theorists in the world, and they start proving some lemmas about where certain digits must be. I write an extremely inefficient mathematical program to just go through the 9 factorial permutations. I don't even bother doing any symmetry arguments. Why don't I bother doing any symmetry arguments?
Savings aren't as significant.
So, but why aren't the savings significant?
Because you can, like, the total search space is pretty small.
The total search space is pretty small. How many times do I have to use the program? Once. If I was going to be running this program many times, then yes, I'd like it to be efficient. But the amount of time it would take me to code it more efficiently is actually longer than the time it would take the inefficient program to run. It actually took less time to write the inefficient program and have it run than to spend a little bit of time and code it carefully and make sure I didn't make a mistake. And since I only needed it once, that was a much better way to approach it. So you really want to be aware of what problem you're doing and what you need to look at. So here, there's 6 possible games. If I go back to chess now, could we use this to help us with the queen game? How could we use this to help us? Yes.
Well, for beginning moves, right, so first of all the corners are the same.
Good.
And then any square that's on the edges 1 from the corner is also the same.
Okay.
So, yeah, and then obviously that third one.
So there's only 6 opening moves. So is it worthwhile to encode that? Or does this now make it harder to actually write the program? Because now I have to deal with the fact that once I go over here, now it matters maybe which squares there are. Otherwise, I'm choosing 5 numbers from 25 numbers, and those are going to be the locations of the queens. So the question is just, which is easier to code? Which is faster to go through? If you do something like this, you will have some savings. But if you choose the 6, that's going to be really easy to code, and then you can still use your symmetries. So these are things to think about, that sometimes it's actually better to do the more painful brute force. If it's not horrible, it's better than coding an improved version. There is, however, a wonderful observation that makes this problem a lot faster than 25 choose 5. So I'll give you a moment to think. So this is one of the best ideas in mathematics. Sometimes what you do is you look at the dual problem. Ah, you just had the moment. Yes.
If you think of putting the pawns on first and then like think of them as queens and they can't be threatening.
Yes. So you could put down 3 queens so that 5 squares are safe, and then change all the queens to pawns and pawns to queens. And now, rather than putting down 5 objects, you're now putting down 3 objects. Now again, for this particular problem, it doesn't really matter. It's small enough that we can do it by brute force in a reasonable amount of time. But this notion of sometimes it's easier to look at a dual problem. Has anybody here done Fourier analysis? Have you seen Poisson summation? Okay. But you often can convert one problem to another problem. And if you can find a related problem, often it is easier. And so here now, rather than putting down 5 queens so that 3 pawns are safe, I can put down 3 queens so that 5 pawns are safe. And then flip all the queens to pawns and pawns to queens. This is one of the key ideas in a beautiful subject called linear programming. This is what airlines use, for instance, to figure out how they should fly and choose their routes. And you can often prove how close you are to the optimal solution by looking at things called dual problems. So I want you to be aware of stuff like this. All right. So now that we have this, we're almost done with the first day of class, I always want you to be asking questions. How could you generalize this game?
As in like making the side lengths arbitrary and like a number of queens arbitrary?
Yeah, so you could say maybe we'll look at an n by n board. And then the question is, how many pawns can you place on an n by n board with n queens? How do you think that number grows? This is not much of a data point. Well, can we do, sometimes you go back and do earlier cases. Let's do the 1 by 1 board. All right, 1 by 1 board is not that interesting. 2 by 2 board, also not that interesting. 3 by 3 board is the first board that could potentially be interesting. Is there any way to put down a pawn safely on a 3 by 3 board? It's people saying no. So maybe the 4 by 4 is the first one that becomes interesting. Or maybe it is the 5 by 5. How many of you have ever heard of the OEIS? The Online Encyclopedia of Integer Sequences. There really is such a thing. And if you have a pattern of numbers, what you can do is you can go to the OEIS and you can put in those numbers, and it will tell you all the sequences it knows that starts with that. And if you don't have many terms, you could get over 1,000 entries. And as you start to get more and more terms, it will tell you, actually, I think it has to be one of the following. And so, I will end with this. I will just... So can somebody think of a fun sequence? Don't tell me what it is. Does somebody have a fun sequence? You've got to be able to rattle off a couple of terms of it. Anybody have one?
7.
Okay, 7.
1 7.
1 7.
1017. Sorry. 1117. And then 3000. 3117.
All right. So is the next number 13,217?
Yeah.
I'm sorry, 132,117.
Yeah.
So, okay. So this was very nice, displaying 1 of 1. But it goes down and it says, here's an example, here's some code to generate this. This is, not a particularly great one. If I got rid of the last one, there were 2 ones that work. And the other one is primes of the form, which is, If I give just your first 2 terms, now it found 1,709. But so for the first one, it says the greatest prime dividing n for n greater than or equal to 2, with a 1 equals 1. And then look at what, it gives you a bunch of references, it gives you links, it gives you formulas, various codes. So there's an enormous wealth of information available. Frequently, the hardest thing in mathematics is figuring out what you're trying to prove. So if you can do some simulations, if you can gather some data and make some conjectures. Does everybody know how to prove that the sum of the first n integers is n plus 1 over 2? This is the standard induction proof. We'll be doing induction soon. And then you can prove formulas for the sum of the squares and the cubes. If I tell you the formula for the answer, the problem is not that bad. If I don't tell you the formula, it's a little bit harder. And what you can do is you can use something like this to guess what those answers should be. So this is a really good website to know. All right, any other questions for first day of class?
I have an off-the-camera question about the green chicken.
Okay, so I will then be turning off the camera at this moment. Was it recording?